Hello. Christ is God. Love you, Father. Love you, Jesus Christ. And the enemy has people of all races working for him, right? And so Christians of all races, we must unite, right? This battle, this enduring battle we're on, is not a matter of color, but a matter of right and wrong and good and evil, right? And we will win. It's been written. It is written, right? So it's just a matter of time. But yeah. So it says the train leaves at 9, in case you can't see it. On an 80-mile journey, a second train leaves at the same station. All right, that's important, right? Okay. At 9:10 and catches the first train at 10:30. So what we want to know is the rate of the second train, right? Okay, now, in any rate question, the first thing you should do is write automatically. This should be an automatic, right? D equals R times T. I call this the dirt formula. It's very rare that I insist on, like, you know, a particular methodology to solving a problem, but in this kind of a question, I do insist that the first thing you do is write dirt. Distance equals rate times time. Got it. So then all you have to do is, in this equation, figure out what D has to be, what R has to be, what T has to be, and the problem kind of solves itself. Now, what's really crucial in this question is to understand that 80 is not D. It's very tempting to think that 80 is D, but it's not, right? And that's because, like, the first train leaves at 9, the second train leaves at 9:10, and the distance covered by the time the second train catches up to the first train is unknown. We can figure it out, but that's not that 80. So that's not D. That's super important to figure out. Okay. Otherwise, the time is probably the easiest thing to fill in. R obviously is what we're seeking, the rate of the second train. So we don't know R. That's what we're solving for. T has got to be the difference between 9:10 and 10:30. That is 80 minutes. So 80 minutes is 80 over 60 of an hour. And so one thing to know is, like, usually, not always, usually, like, this dirt formula is kind of like assumed to be in hours, right? So the time is supposed to be in hours. Okay, not necessarily, but usually. Okay, 8 over 6. If you convert all the units, obviously, into minutes, then you'll be fine, right? So 8 over 6 is 4 over 3, 4/3 of an hour. That's what we've got. So T, we know, is 4/3. Got it. R, again, we're solving for. So we have to figure out what D is. But there's something more crucial we have to do before we worry about what D is. Like I said, in the context of the question, we figure out what D is. That crucial thing is, in these kinds of problems, either it's just one object moving, right? In which case, you know, there isn't much thinking that you have to do, or it's two objects moving, which is a case here. And so let's say those two objects have R1 and R2. Since, again, what we're solving for is the rate of the second train, I didn't need to put a subscript on this R. It's, you know, we have, like, put on our head that that's what we're doing, solving for the rate of the second train. So technically it should be R2. Anyway, let's say that you have two objects moving at rate R1 and R2, right? Cars, trains, whatever, right? Flying saucers. Okay, let's say this first one was moving at, just for the sake of argument, 50 miles per hour. And then the second one is moving at 40 miles per hour, right? First of all, take note, one of them is moving at a faster rate than the other. Second is, what is crucial is that you figure out if the two objects are moving in the same direction, right? So if it's 50 here and 40 here, I'm pretty sure you've noticed this, like, you know, sitting in a car, in your mom's car, whatever, another car is passing by you in the same direction, even if it's going 50 miles per hour, if you're traveling 40 miles per hour, it looks like it's going at 10 miles per hour. That's how it feels. Whereas if you've been on opposite sides of a highway, right, and you're moving past another car, let's say moving 50 miles per hour again, you're moving at 40 miles per hour, and it feels like that car is zooming past you. So it feels like it's traveling at 90 miles per hour, right? So what I'm saying is, if the two objects are moving in the same direction, then you have to subtract R1 and R2. if the two objects are moving in opposite directions, you have to add. Because like, let's say you have a certain amount of distance, right? Let's say you have this D to cover. Then if the objects are moving away from each other, then they're both helping grow the gap, right? And that's kind of like why you have to add the two rates. And obviously then the other situation is they're either moving together in the same direction, they're moving away, so they're moving towards each other. And once again, if they're moving towards each other, they're working together to close the gap, so then you add the rates. So you add the rates, they're moving away from each other or towards each other. And then you subtract the rates if they are going in the same direction. Okay. Cool. Christ is God. Another insert. Okay. Well, no fact, but I insist on repeating it. Okay. So what do we do in this situation? Well, since they're moving towards each other, we must subtract them, right? So we must do R1 minus R2 or R2 minus R1. That's crucial. Because, and I didn't tell you how fast the first train is moving, right? So, because we have to know that. So let's say that the first train is moving. We do have to know that. The first train is moving at like 50 miles per hour. Why not? Right? And so we're trying to figure out the rate of the second train. So here's a crucial thing, right? Well, so do we do, if this is R1, do we do R1 minus R2? And obviously R2 here is the unknown. So R2, let's call it X. So do we do R2 minus R1 or do we do R1 minus R2? And the answer should be very clear. We do X minus 50. So that's R2 minus R1. Why? Well, because the second train with rate R2 catches up to the first train. So it could not have caught up unless it was traveling faster. So we want to take the positive difference. This one is traveling 50 miles per hour, so the second train must have been traveling at a faster rate. Okay. So made a lot of progress. Got it. So we come here and be like, D's right here, and R is X minus 50. Got it. And so then the last thing we must figure out is, and I'll need this, right? Y'all have seen this? Okay, the last thing we must figure out is the D, right? And the D must be, so like the first train is traveling at 50 miles per hour, right? And since the second train caught up at 10:30 and the second train left at 9:10, it took 80 minutes of like distance to create the gap between the two trains, right? Like no, hold on, that's not the way to say it. So there was an existing gap between the two trains. No, that's not what I want to do. No. Now finally, to figure out what D is, since the second train left at 9:10 and the first train left at 9, D must be the gap between the two trains that we like closed, right? Since we've subtracted the rates, what we want to do is like kind of subtract from the onset the existing gap between the two trains. Okay, since the difference between 9:10 and 9 is 10 minutes, the gap between the two trains at the onset has to be the amount that this first train traveled in 10 minutes. So that's got to be 50 miles per hour times 10 minutes in hours is 10 over 60. Cancel that, 50 over 6. Okay, so then I'm going to write 50 over 6 miles, right? What's that, like less than 10, a little less than 10, right? Okay. So now, to solve for x, we're all set. We multiply both sides by 6. I'm a man of Jesus. I like sevens, so I'm just gonna put it in my head. 6 over 2 or 6 over 3 is 2, right? So I'm gonna write times 2 here, and that makes 8. So I can knock off that 4 times 2 into an 8. Put it right here, right? And then now we can cancel this into a 25 over 4. So 25 over 4 is equal to x minus 50. So then we add 50 to both sides, and so the second train must have been traveling at 50 plus 25 over 4 miles per hour. I'm not like much of like an arithmetic man, so I'm gonna leave to you to figure out what that number is. It's not very hard to figure out. Like 24 over 4 is 6, so 6 and 1/4. So what does that make? I'm not saying 7, 7, 7, 7, 7, 7. Jesus is God.